Welcome. In this quick video, we'll explore the fundamentals of the refrigeration cycle. Whether you're new to the field or just need a refresher, we'll walk you through the essential principles behind cooling and heat pump systems. The refrigeration cycle is the core of all modern cooling systems, from your household refrigerator to industrial HVAC units, and even modern heat pumps. At its heart, this cycle relies on a simple yet powerful principle, using pressure and temperature changes to transfer heat from one place to another, all through a refrigerant. Let's break down the main components in the refrigeration cycle. 1. Compressor. The compressor is the heart of the refrigeration system. It takes in low-pressure refrigerant gas from the evaporator and compresses it, increasing both its pressure and temperature. This high-pressure gas then moves on to the next stage. 2. Condenser. The high-pressure, high-temperature gas flows into the condenser, a heat exchanger where it releases its heat to the surrounding air or water. As the refrigerant cools, it condenses into a high-pressure liquid. This phase change is crucial, as it allows the system to expel unwanted heat. 3. Metering device. The high-pressure liquid refrigerant is directed through a metering device, such as an expansion valve or capillary tube. This device controls the flow of refrigerant into the evaporator. As the refrigerant passes through, it experiences a significant drop in pressure, cooling rapidly and becoming a low-pressure, low-temperature liquid. 4. Evaporator. In the evaporator, another heat exchanger, the cold refrigerant absorbs heat from the environment, be it the inside of a refrigerator or the air in a room. As the refrigerant absorbs heat, it evaporates into a low-pressure gas. The cycle then begins again as the gas returns to the compressor. For heat pumps, there's an additional component known as the reversing valve. This valve allows the refrigerant flow to switch direction, effectively reversing the heat exchange process, pulling heat from where we used to send it, and sending heat to where we used to pull it from. Explaining the theory. The pressure-temperature relationship. The refrigeration cycle hinges on the principles of the ideal gas law and the latent heat of vaporization. According to the ideal gas law, increasing the pressure of the refrigerant raises its temperature, allowing it to release heat in the condenser. Conversely, when the pressure drops in the expansion valve, the temperature decreases, enabling the refrigerant to absorb heat in the evaporator. The latent heat of vaporization plays a crucial role during the refrigerant's phase changes, ensuring efficient heat transfer throughout the cycle. Think of it like this analogy. Imagine using a sponge as a refrigerant and your hand as the compressor, with water representing heat. You could expand the sponge in a wet area inside your home, absorbing water. Then, even if it's raining outside, compressing the sponge forces the water out. By bringing the compressed sponge back inside and letting it expand again, you can absorb more water. Similarly, in the refrigeration cycle, heat is absorbed and discharged using changes in pressure and the physical properties of the refrigerant. In summary, the refrigeration cycle relies on the controlled manipulation of pressure and temperature, governed by the ideal gas law and the latent heat of vaporization, to move heat from one place to another. Understanding this process is essential for any maintenance engineer, as it forms the foundation of all refrigeration and air conditioning systems.